A sunspot has grown so large it could have catastrophic consequences.
The size of sunspot number Arkansas 3664 is increasingly resembling the Carrington sunspot, which in 1859 caused an apocalyptic particle storm, putting the United States in a state of emergency for weeks. The gigantic sunspot, now visible on the surface of the Sun, is already 15 times wider than our Earth, with a length of 200,000 kilometers and will probably continue to grow. This means that the event of 1859 could repeat itself, and our entire civilization could collapse within minutes.
Arkansas 3664 is one of the largest and most active sunspots of the current solar cycle.
Sunspots are areas on the Sun's surface caused by intense magnetic activity.
These spots appear darker than the surrounding solar surface because they have a lower temperature.
Typically, sunspots are about 1500 K cooler than their surroundings and can reach diameters of several thousand kilometers. On average, sunspots have a diameter of about 16,000 kilometers, but Arkansas 3664 is already exceptionally large at nearly 200,000 kilometers, towering over 15 times the size of the Earth. If the sunspot continues to grow or does not slowly disappear, we must expect repercussions that could lead to a catastrophe on a global scale. Solar storms have the potential to cripple our entire modern civilization in a matter of minutes due to solar flares and coronal mass ejections, where large amounts of plasma and magnetic fields are thrown into space. Powerful geomagnetic storms can hit the Earth, destroy power grids, and paralyze communication systems. Arkansas 3664 has already produced several flares that have released enormous electromagnetic radiation and even caused bizarre light shows in the Earth's atmosphere at a regional level. In early May 2024, auroras, which are otherwise only visible in the extreme north and south of the globe, appeared in regions where these phenomena do not normally occur. We have been spared truly fatal effects, but can we be sure things will stay that way? Sunspots are visible to the naked eye.
Imagine that the Sun is 109 times larger than the Earth.
Average sunspots are usually tiny compared to these dimensions and are hardly visible to the naked eye from Earth, especially since it is not advisable to look at the Sun without protection, which can lead to blindness.
Arkansas 3664 is different. This spot is already so large that you can see it with the naked eye, protected by specially certified solar eclipse glasses.
The best time to observe sunspots is during daylight hours when the sky is clear, and the Sun is high in the sky.
Locations with clear skies and low atmospheric pollution offer the best observation conditions.
Sunspots like Arkansas 3664 are normal in our Sun's cycles and are caused by intense magnetic charging and convection processes within the Sun, where masses of hot plasma rise, cool, and sink again, creating and twisting strong magnetic fields. If they occur in unusually large sizes and activity like AR 3664, this could indicate a particularly strong concentration of magnetic field in these areas of the Sun. These sunspots are rare, and we need to understand them better because we have become extremely vulnerable as a civilization. A strong solar storm like the one in 1859 would have a very different outcome this time. The Carrington Event of 1859 is a warning. Imagine an entire nation thinking for a few hours and days that God's judgment had fallen upon them. When people in the United States looked up at the sky at that time, they saw a fiery sky and many thought God's wrath was coming from the heavens. At the same time, the few existing electrical systems sparked, telegraph wires hissed day and night, and the fledgling communication networks were paralyzed.
No one knew what had really happened.
It took weeks for news to reach the remotest settlements in the Midwest and the most isolated stretches of land. Only one man correctly interpreted the events, the British Richard Carrington. Carrington suspected that a massive solar storm had reached Earth and that electromagnetic charges had penetrated Earth's atmosphere, causing problems with electricity and magnetic devices. The Carrington Event peaked on September 1 and 2, 1859, but the consequences, the fiery skies, lasted for weeks. The United States was particularly affected, but the effects were also felt elsewhere. Some telegraph stations in the United States were able to continue sending messages even without batteries, powered only by the geomagnetic storm. Elsewhere, the charges were so strong that electrical shocks escaped from the telegraphs, setting paper on fire. Imagine, in an age when there were practically no means of communication, only a few telegraphs, newspapers, stagecoaches, or messengers to spread the news. The fastest means of communication broke down, and it took weeks for the news of the solar storm to spread. The sunspot observed by Carrington was exceptionally large, although the exact dimensions are not documented. The eruption he witnessed was a massive coronal ejection that hit Earth in just 17.6 hours. At the time, the Carrington event was relatively mild because humanity was not as technologically advanced as today. Once it was understood that it was a natural spectacle, people could enjoy colorful auroras visible even in Cuba, Hawaii, and Queensland, Australia. Transferring the scenario to today, the danger becomes immediately clear. Events like this massive flare can completely cripple our power supply. If power grids collapse, all systems that rely on electricity will fail. At most, emergency generators could help with fuel for a while and provide emergency power to important systems like banks or food production companies. But if the storm lasts longer, things would get bleak. Imagine masses of food rotting because refrigeration systems fail, ATMs going on strike because there is no electricity, gas stations not working because distribution systems are now predominantly based on electricity.
Cell phones would no longer work, the internet would be unavailable, and the TV screen would remain mute, as would the radio.
Sparks could fly from outlets, fires would be commonplace, and affected people would not even be able to call the fire department. Satellites, essential for communications, weather forecasts, and GPS navigation, could be damaged or destroyed, causing dramatic disruptions lasting weeks or months.
Navigation systems for airplanes, ships, and cars could fail, and accidents would be inevitable. A study by the National Academy of Sciences estimates that an event of Carrington's magnitude today would cause damage of up to $2.6 trillion in the United States alone. The damage could plunge us into a global crisis, bankrupt countries, and ultimately collapse our entire order. Now imagine, such a particle flow could hit us at any moment. Arkansas 3664 is just the beginning.
I bet you didn't know that Arkansas 3664 has already produced M-class flares, some of which have hit us.
Flares occur when sunspot magnetic fields twist and release large amounts of energy. M-class flares are moderately strong solar eruptions on the logarithmic scale of the National Oceanic and Atmospheric Administration, responsible for classifying solar flares. M-class flares are 10 times stronger than C-class flares but less intense than the more powerful eruptions, X-class flares. M-class flares can cause short-term radio blackouts in polar regions and trigger small geomagnetic storms that sometimes produce visible auroras. With X-class flares, we are already dealing with the strongest solar flares, at least 10 times more intense than M-class flares, and can cause severe power outages if they hit us directly. The good news is that so far, the most violent flares have passed us by, so we've been lucky. But according to researchers, it's only a matter of time before a violent X-class flare hits us and puts our global security to the test. Indeed, surveys have shown that almost no one on Earth is aware of the danger. Strangely, when respondents are spontaneously confronted with the idea of a strong solar storm, most say they still feel safe. This is because a devastating solar storm has never occurred in our modern civilization. People have no internal standards regarding the magnitude of potential problems and consequences, so they feel safe.
The fact that tiny, invisible solar particles can be so dangerous to us is underestimated. The first thing we need to know to protect ourselves effectively is that it can happen at any time. If in the morning your electrical equipment stops working, sparks fly from outlets, and the sky catches fire, you know well what has happened. You can also protect yourself from threats like these by always keeping an emergency supply of food, clean water, and money at home. If distribution networks fail, you should be able to get by without shopping and money for at least a week.
Of course, researchers and governments around the world are also trying to protect us. The first measure is better and better monitoring of the sun. When spots like Arkansas 3664 appear, global observers issue warnings to institutions like governments, airlines, satellite operators, and power companies. International cooperation is taking the problem seriously, and experts are trying to develop strategies to protect our global infrastructures and power grids from flares and their effects. In practice, this means improving the structures of power lines, resilient satellites, emergency communication networks,
and technologies capable of handling strong electromagnetic fluctuations.
NASA's Solar Dynamics Observatory is one of the most important facilities for monitoring the sun.
Since its launch in 2010, the SDO has provided high-resolution images and data on solar activity 24 hours a day. It continuously observes the sun at different wavelengths of light to provide an even better picture of events like solar flares and coronal mass ejections. Thanks to intensive monitoring of the sun, solar maps have been created, and the cycles and rhythms of solar activity are increasingly understood.
This should make more accurate predictions and anticipations possible.
By analyzing these data, scientists can now better predict the likely development of Sunspot Arkansas 3664. However, it remains to be asked whether this can really protect us in an emergency. The sun can spontaneously generate a flare that can reach us in half an hour. How much time would there really be to land planes and secure power grids? Thanks for watching. Leave a like and subscribe to the channel.